Section 7.3. The source-free RL circuit. You can find a circuit in the slide, and there is a resistor and an inductor, but there is no source inside. However, the inductor is charged, so there is an initial current in the inductor, which is I0. So when t equals 0, there are energy stored in the inductor, which is W0 equals 1 over 2 multiplied by L multiplied by I0 square. And we can use KVL to get the equation VL plus VR equals 0. And then we replace the voltage with the current, and we get this equation L multiplied by di over dt plus R multiplied by I equals 0. Obviously, this equation is a first-order equation. So this circuit is a first-order circuit, and there's no source inside, so it is a source-free RL circuit. And we can solve this equation by integrating both sides, and then we get the final solution IT equals I0 multiplied by e to the minus RT over L power. And then we define the time constant of RL circuit, tau equals L over R. So we rewrite the solution as IT equals I0 multiplied by e to the minus t over tau power. And you can find this solution is very similar to the previous, which from RC circuit. The definition of the time constant tau is just like the previous one. That means time constant tau is the time need for the current drop to the 36.8% of the initial value. Now we have the solution of the current I, and we can get the value of the voltage by Ohm's law. VRT equals I multiplied by R equals I0 multiplied by R multiplied by e to the minus t over tau. And then we can get the energy dissipated by the resistor. WRT equals the integral from 0 to t with respect to p lambda multiplied by d lambda, where we can put the expression of p tau inside, and then we get the final solution. WRT equals 1 over 2 multiplied by L multiplied by I0 square multiplied by 1 minus e to the minus 2t over tau power. As you can find from the expression, the energy dissipated by the resistor is dropping when the time is increasing. Inside this expression, you should notice that tau equals L over R. So the key to working with a source-free RL circuit is to find two things. The first one is the initial current I0 through the inductor. The second one is the time constant tau of the circuit. This is the end of this section.